All right, this is it, the final episode in our Oracle 26 AI series. And for this one, we're going to flip the script on a problem that's been bugging data scientists for, at least a decade. We're going to challenge the way we've always done machine learning and ask a really simple but kind of radical question. Have we been doing it completely backwards this whole time? Let's dive in.
You know the drill, right? For what feels like forever, the ML workflow has been the same thing over and over. You've got this beautiful, massive, super secure database, and what's the first thing you do? You start the slow, painful process of yanking all that data out of it to get it to your code. Well, Oracle 26 AI comes along and asks a crazy simple question. What if we did the exact opposite?
So here's how we're going to break it all down. First, we'll talk about the data movement problem itself. Then, a quick history of the headaches that got us here. After that, the good stuff, the in-database revolution. We'll even do a little code versus code showdown and wrap up by looking at what this means for the future. Let's go.
Okay, let's kick things off with something I think every single person on a data team knows all too well. That feeling, that soul-crushing feeling of just watching a progress bar slowly crawl across your screen while you're trying to move a massive data set. Yeah, that.
I mean, does this sound familiar to you? You finally kick off that big model training job, right? And for the next, several hours, what are you doing? You're just watching. Watching the CPU meters spike to 100%. Watching that RAM usage flash red, just praying the whole server doesn't fall over. You're literally watching your weekend vanish right before your eyes.
And for years, this has been the standard playbook, right? Export the data, transfer it over the network, load it into memory, and then pray. And trust me, when you're dealing with hundreds of millions of rows, that's not just a little prayer. It's a full-on, desperate plea to the server gods to please don't let this thing crash.
And you know what's wild? The whole time this is happening, your Oracle database is just sitting there, metaphorically tapping its foot, thinking, hello? I already have all the data. It's right here. It's safe. It's organized. Why in the world are you dragging it across the network like it's 1999? And you know what? That's a really, really good question.
So that begs the question, right? How did this incredibly inefficient, kind of clunky workflow become the standard for everyone? Well, it wasn't on purpose. It actually happened because of a few historical quirks that basically forced us down this path, creating all the problems we're still dealing with today. So let's do a little digital archaeology.
Yeah, it really comes down to three big reasons. I've kind of nicknamed them the Python gravity well, the memory wall, and the copy-paste pipeline. Let's unpack what each of those means.
Okay, first up, the Python gravity well. Think back to the 2010s. Python just exploded. It became the absolute center of the machine learning universe. All the coolest, most powerful tools, we're talking scikit-learn, XGBoost, TensorFlow, you name it, they all lived in Python. And just like gravity, it had this incredible pull. If you wanted to use the best stuff, you had no choice. You had to pull your data into its orbit. Next up, the memory wall. Look, those separate Python servers are great for a little while. They're awesome for smaller jobs. But the second you try to give them a really beefy dataset, like, say, 200 million rows, you slam right into a hard physical wall. The server just gives up. It either crashes completely, starts swapping memory to disk, which slows things to an absolute crawl, or suddenly a model that should have taken 20 minutes is now scheduled to finish in 14 hours. It's a nightmare.
And finally, all of this led to what I call the copy-paste pipeline. And suddenly, every single machine learning project looked exactly the same. It was this super fragile, rickety chain of events. Pull data from Oracle, dump it into a CSV, move the CSV, load it into Python, train the model, and then somehow figure out how to shove that model back into Oracle. It was slow, it was expensive, and maybe worst of all, it meant you had copies of your precious data scattered all over the place. Not great.
Okay, so we've laid out the problem, right? We've walked through the history, a whole decade of gravity wells, memory walls, and these shaky pipelines. So now, let's talk about the fix. This is where Oracle 26 AI is an absolute game changer. And it all boils down to one simple but totally revolutionary idea. What if you train the model inside the database itself?
And the crown jewel of this whole revolution is in-database XGBoost. Now, I want to be crystal clear about this. This is not a wrapper. It's not some clever hack that's secretly calling Python in the background. No way. This is the actual XGBoost algorithm, rebuilt from the ground up in C to run natively, right inside the Oracle database kernel. That means it has direct, super fast access to all the data and all the hardware.
So what does this actually mean for you day to day? Well, it means you can say goodbye to a lot of headaches. Goodbye to moving data. Goodbye to managing separate Python servers. Goodbye to RAM bottlenecks crashing your jobs. Goodbye to training on stale data that you exported 6 hours ago. And crucially, goodbye to the security risks of having sensitive data copied and pasted onto different machines.
But wait, here's the real kicker. Because the database itself is now the training engine, it can perfectly manage and optimize everything. The memory, the CPU, the storage, the whole shebang. And the result? Honestly, it's kind of mind-blowing. In benchmarks, we've seen complex models that used to take hours, literally hours to train, now finish in just a few minutes. That is a massive difference.
You know, nothing shows the power of this change better than just looking at the code. Forget the theory for a second. Let's put the old way and the new 26 AI way right next to each other and see the difference.
Okay, so on the left, you've got the old Python approach. You've got code to load the data from Oracle. Then you have your XGBoost training code. Then you need more code to save the model back. It's a whole process. Now look at the right. That's the 26 AI way. It's one clean, easy-to-read SQL statement. You just tell it, create a model, predict this column, use this algorithm from this data. Boom! That's it. You're done. The database takes care of everything else.
I mean, look at that. It perfectly sums up the whole idea. No more Python servers to babysit. No more moving data around. No more fragile pipelines breaking in the middle of the night. No more headaches. It's just SQL.
All right, as we start to wrap this up, let's pull back and think about what this really means. Because this isn't just about making an old process a little bit faster. This is a fundamental shift. It's about changing what a database even is. For decades, the golden rule of computing was you move the data to the code. That was just how it was done. But what we've just seen, especially for huge machine learning jobs, is that that model was never efficient, it was never all that secure, and now we know it was never even necessary in the first place.
With Oracle 26 AI, the database is evolving. It's not just a place to store your data anymore. It's the storage, it's the compute engine, it's the query optimizer, and now it's also the machine learning engine. It's everything, all in one place, working together seamlessly.
So yeah, this isn't just some new feature in a long list. It's a whole new direction. This is the future of databases, and it's for sure the future of machine learning. The old model is officially dead. From now on, we bring the code to the data. And that brings us to the end of our 5-part journey into Oracle 26 AI. Thanks so much for joining me on this deep dive. The paradigm has shifted, and the question for all of us now isn't if you'll bring your code to the data, but really, when are you going to start?